Welcome to Auto Nerds. Today we have a 2003 Jeep Wrangler. Now the Jeep 4-liter has been proven to be a reliable workhorse. It has been in production for many years. But this one has a couple of unusual issues. This thing has been from shop to shop. And as you can see, all of the conduit has been stripped from the harness under the hood. And they have placed the coil pack here off to the side with spark plug wires leading to the plugs. This vehicle will start in idle, but if you touch the throttle, it'll just stumble and stall. Codes P0351, 352, and 353 were stored, and a P0306, ignition coil primary circuits 135, and cylinder 6 misfire. Possible causes for the ignition coil primary circuit codes, according to the service information: a good trip equal to 0, ASD relay, ignition coil resistance, coil control circuit open, or ignition control circuit shorted to ground, or PCM. So first, let's take a look at coil primary current and voltage for coil number 1. This is the coil that fires cylinders 1 and 6. At first glance, this almost looks like some type of multi-strike system. However, according to the service information, this is a standard waste spark system. So this might be a good time to take a look at the triggering system. We'll take a capture of cam and crank sensors. Now something looks very wrong here, but I'm going to bring in some reference waveforms to help with our analysis. Now there are two problems here. First, the cam signal's fallen apart, and second, the cam-crank relationship is off. You notice in our reference waveform, we have 3 sets of 4 pulses within each cam pulse. Now in the waveform we're testing, they appear to be out of sync. And here we have an illustration of the cam sensor. This cam sensor fits in place of the distributor used in earlier models, and it's also adjustable. Now according to the service information, the engine should be rolled over to top dead center on number 1 compression stroke, and a toothpick inserted into a hole in the side of the cam sensor assembly before installing. Now this will get us close enough to run, and with the scope we can sync more accurately. And here's another capture of the cam crank signals after the cam sensor was replaced. And you can see we now have a nice clean square wave out of the cam sensor, and is now synchronized with the crank sensor. So that takes care of the coil driver issues, but we now have the P0306 cylinder 6 misfire issue. This code seems to set shortly after a cold start. This is a problem that has plagued this vehicle from day one. It's been in many different shops with many different parts replaced, including coil assembly, number 6 injector, the PCM, cylinder head, even cam and lift aeration were checked. So let's put the scan tool on it and see if it shows any misfires after a cold start. And there it goes, just a couple of minutes after cold start, we see the misfire counters counting up. And then a couple of minutes later, the misfires stop. Did some basic tests. Spark plugs look good. We went ahead and swapped the plugs with other cylinders to make sure that the misfire wasn't going to follow the spark plug, and it didn't. I took a look at freeze frame data. Nothing too unusual here. It looks like misfire started about 111 degrees Fahrenheit and 960 RPM. And the fuel trims don't look too badly out of range. So we decided to let the engine cool again. and take a look at secondary ignition for cylinder 6. This capture was taken while the misfire counters were counting up, and you can see it's very turbulent. This is the same cylinder after the misfire stopped. All the turbulence went away and it looks good. So what could be causing such a disruption in the spark line for just a couple of minutes during warm-up? Let's take a look at the injector circuit just in case. So I took about a 6-minute capture here. Let's zoom in on the area where the misfires were occurring. So it looks like our injector voltage supply and driver are working properly. But how do we know the injector is flowing as it should? Now this is a returnless fuel system. Now the fuel inlet's at the front of the rail and the number 6 injector is at the rear. If there was any debris in the fuel system, it's likely to find its way to that number 6 injector. So we thought we'd put a pressure transducer on the fuel pressure test port, and then we'll look at number 6 injector voltage for reference. Now here we have a little more than one full cycle, and we can see the pressure drop for each injector. They seem to be consistent. Now after trying a manual compression test and leak down test, and all cylinders looking good, we decided to try a running compression test. Now running compression tests with a gauge have been tried before, so we're going to try a different approach by screwing a pressure transducer hose in place of the number 6 spark plug. Now here we set the scope up at 50 seconds per division, giving us 8 minutes and 20 seconds on one screen. Now we started the vehicle cold and let the scope run while the engine warmed up. You can see how compression started dropping at about 1 minute and 40 seconds. It keeps dropping for a few minutes and then quickly returns. Let's zoom in on the low compression area. Now, I placed a cursor on top of the compression peaks, and we can see up here it drops to about 45 psi. Now if we zoom in on the higher compression area, compression increases to about 70 psi, so about a 25 psi difference. So we thought we'd take a look at 2 companion cylinders at the same time for compression. We placed a transducer in cylinders 1 and 6 and started the engine cold. Now channel A, the blue trace, is cylinder 1. Channel B, the red trace, is cylinder 6. And we can see when cylinder 6 starts dropping off, cylinder 1 is much more stable. Since the cylinder head has been replaced because of the cylinder 6 misfire, it's not likely to be a valve hanging up. The cam lift and duration have already been checked. So what's left? Lifters, push rods? We checked the push rod length. They checked out just fine. We could see through them. So we decided to try an experiment. We placed shims under the rocker stands for both the intake and exhaust valves. Just enough to give each valve a little lash. We tried another cold start with the scan tool attached, watching the misfire counters, and found no misfires. We repeated this test with the same results.